Hey, what's going on, guys? Against here. Last video we implemented our masking of the rook relevant occupancy bits, and by the way, I need to change the commentary slide a little bit. So mask relevant rook occupancy bits. Okay, now it's much better. And the next thing to consider is actually to start generating both rook and bishop attacks on the fly for the further magic bitboard purposes. So I mean, like, in order to create those pre-calculated attack tables for slide-in pieces, we actually need to initialize them first, and the two functions that we're supposed to be writing within this video actually would serve that purpose of initialization of the both rook and bishop attack tables. So they would look like almost the same like this mask bishop attacks and mask rook attacks, with the only difference that instead of skipping the board edge, they would be hitting the board edge. And also we'll add an additional argument into the function itself called a block bitboard. So we would be bitwise ending our target square with this block bitboard, and that would actually allow us to drop the for loop, to break out of the for loop in case when we hit some sort of a piece on board. So it's probably much better to implement and demonstrate rather than to explain. So without further ado, let's actually start writing some code. So the very first thing I would like to consider, I just want to make use of this mask bishop attacks function here, and I just want to paste this in, and I call this generate bishop attacks on the fly, and I call this function bishop attacks on the fly. And also, apart from the square where the bishop is where the bishop has landed, we need to specify the U64 unsigned lone bitboard type variable called block. So here we would be passing the bitboard having some blocking bits, or regardless of what kind of piece is that, basically. Okay, so now I just want to, so well, first of all we need to make it hit the board edges. So 7, and here 0, 7, 0, 0, 0, and here actually generate bishop attacks. Okay, so let me check this one more time. So get a bitboard, false ranks. Okay. Okay. So first, I just want to check that out if it's gonna be hitting the edges of board, which it should, basically, and then we'll go for implementing our logic to break out of the for loop if hit a piece. So I just want to print the bitboard, and here bishop attacks on the fly, and let's put it on D4, and instead of the blocker I will just pass the empty bitboard, this unsigned this 0 unsigned long constant, just for a while, so no pieces on board at the moment. So I just want to open the terminal in the current working directory, and by typing make debug, I want to compile the source, and if it compiles, run the BBC binary executable. Okay, so as expected, now bishop hits the board edges as well, but obviously if we just put a piece somewhere, it won't really get recognized there, so it won't drop the attack for a while. So I would now like to create a blocker bitboard. So let's create so we don't probably need this loop at the moment already, so let's initialize let's call this occupancy bitboard, and create a variable u64, let's call it block, or occupancy, doesn't really matter that much, so initially we'll initialize this as 0 unsigned lon, and I'll just avoid calling this one, and instead I just want to print bitboard and this block bitboard, and let's have a look, it should be empty now. And now I just want to set up the blocker pieces. Okay, so let's set the blocker piece on, say, B6. Okay, so set bit block and B6. Okay, we got one on B6. Let's set up one on G7. Okay, G7, and one on, well, let's try on E3. Okay, E3, and let's try one last on, say, B2. Okay, like this. Okay, so okay, here we have up to 4 blockers. Okay, and now as far as we'll start applying our logic to drop to break the for loop, it would actually start working respectively. So here I leave this condition to actually initialize the attack square to bitwise or our attacks with, and with the next attack square along the attack ray. But also I can simply say that if, and now we just want to take this square, copy, paste, bitwise ended with a blocker returns true. In this case we just want to break out of a loop, and let me just run this, and it now should, okay, and the reason why it still doesn't work is because we don't really pass our blocker into the bishop attacks on the fly function, obviously. So we have this block here, and try this again. Okay, so now you see, like, it drops the attack ray at the exact square where the blocker occurs. So we got this blocker on E3, and it just drops here. And now you might wonder that we don't distinguish between white and black blockers at the moment, and we just drop after hitting a blocker, and that's it. But the matter of distinguishing between the color of the blockers would be left to the mode generator part. So when it comes to implementing the pre-calculated attack tables, the casual way of going basically is this, like when we just take care of blockers regardless of color. So that's just the practices that people use out there, and I'm following these guidelines because probably like the most appropriate way of doing things basically. Well, okay, so now we got this ray being dropped at E3, which is good. And also if I put the blocker on G1, let me just so it was on E3, and if I just put the blocker on G1, it should go right to the G1 because it kind of captures on G1. So this is kind of it. Okay, let's drop back to E3 here, and I'll try to do the same, but for all the rest directions here. So and again, like if, and then we just take the offset bitwise end in this with a blocker, and if it returns true, we just break out of the for loop. Okay, now we get now we dropped our attack ray on G7, just exactly in the exact place where our blocker kind of stands there, so occupied by the blocker, G7. So just drop there. Okay, and now let's do the same stuff for the other directions. So if and taking our offset, it was ending this with a blocker and break, and same for this last direction here. So if just break, and now it should drop all the directions as soon as hits some sort of a blocker. So we have a, so we're dropping our attack ray when hit the B6 right over in here, when we hit G7, okay, when we hit E3, okay, and when we hit B2, this is it. So right over in here you can already see an example of the pre-calculated bishop attacks for the square D4, assuming this kind of like occupancy. So when we'll have the same for rooks as well, the only thing that would be left actually is simply to create a table that would contain this like bishop occupancy attack table, this like pre-calculated bishop attack tables, assuming the particular occupancy. And later on we would be using the occupancy itself in order to occupancy and the masked relevant occupancy squares and the magic numbers and some bit shifts. I'll cover this later on in this series, in order to actually index, we would be generating the so-called magic index in order to get the reference of the particular bishop attack table for a bishop on a current given square, assuming the particular occupancy, getting that from the pre-calculated bishop attack tables. So this is kind of it. This is the entire idea behind the magic bitboards, basically. I'm sorry if my English is not perfect enough to explain this, but I hope this would start getting even more clear as far as we will go for our implementation, because I personally prefer the approach when we're just doing things like why I call myself Code Monkey King, because of the principle of monkey see, monkey do. So when you're just seeing something, when you're just doing this, and eventually you're starting getting your understanding. Okay guys, so enough lyrics, and let's actually try to implement our rook on the fly attack function. So I will take this mask rook attacks as the source for it, and here I just say rook generate rook attacks on the fly, and here call it rook attacks on the fly. Okay, so integer square and U64 bitboard type of a blocker. Save and generate rook attacks. So what do we call this? Generate bishop attacks. Yeah. Okay, so now we need to, so let's change this bishop attacks on the fly to actually rook attacks on the fly, and I will now change the blocker respectively. So for now let's have a look. So we have, okay, so I just forgot to hit the board edges before anything else, so let's take care of this. So rook attacks on the fly, so less equals than 7, greater equals than 0, 7, 0. Okay, so now the rook hits the board edges, which is good, and we're already passing the blocker, but blocker is empty. So now let's try to specify the appropriate squares to block the rook attack rays here. So let's try one on d7. Okay, let's try one on d7 and then one on d2. Okay, and then let's take one on b4 and on g4. So b4, g4. Okay, so here is our occupancy map for our rooks. Okay, and as soon as we add our logic to break out of the for loop, as soon as we got a blocker, it should actually go exactly the same way like it was within the bishops. So I'm doing all the same stuff here. So bitwise ending the blocker and break, save, and save here. So it's all about kind of being the same basically. Bitboards only seem to be complicated, but when it comes to the implementation, it's not really that complicated. It's all about the same. And this offset, okay. And finally this one. Okay, let's have a look. Yeah, perfect. So we have our arrays getting dropped exactly in the place where occupancy happens basically. So this is kind of it. And obviously, so yeah, like d2, okay, b4, g4, okay, and d7. So exactly the same. Let's put occupancy from d1 to from d2 to d1, and it would be like there is nothing basically because it hits the board edge. So let's make d2 to d1, okay. And also obviously if we just have some extra occupancy here like this, we don't really care that there is also piece on d1 a part of d2. So like here we can see this. We would obviously drop at the very first occupancy like it happens if you're generating slider piece attacks on the fly. So hope this is quite pretty self-explanatory. Well, okay guys, so I think this is it regarding generating slider piece attacks on the fly for the Magic Bitboard purposes, for the later use in order to initialize our pre-calculated attack tables using the technique of the Magic Bitboards. We have a couple more functions, helper functions to implement before we start actually generating our before generating our pre-calculated slider piece attack tables. And this is it basically. So we are already quite pretty close to the moment when we would actually be able to reference those pre-calculated attack tables via lookup, which would speed up the mode generation process significantly, and that's one of our main goals when we actually deal with this entire pre-calculated attack stuff here. So this is it from my side, guys. Thanks for watching, thanks for following this series. I appreciate your feedbacks a lot, and they really motivate me so much, and I'm starting getting more and more feedbacks every day from you guys, and really lots of guys starting subscribing to this chess programming channel. I want to thank you all for doing this, because it keeps me feeling like what I'm doing is not for nothing basically, and it's not about to get into the void and like into the black hole without no response, but getting this feedback is incredibly important for me, guys. So if you have any issues or questions arising during compiling the code or understanding how it works, please feel free to leave the commentaries below this or whatever video within this series, and I would be happy to help you by answering those questions and trying to help you solve the issues arising with your own arising on your side, basically. So again, like, this is it from my side. Thanks for watching. Until the next time, and take care.